Welcome back to another video. In this video we'll have a look at Python encapsulation as part of object-oriented programming modules. Encapsulation in Python is one of the fundamental principles of object-oriented programming, and it's in particular important when you are sharing your code with other programmers, which is people who want to work on the same code. It refers to the concept of bundling the data, which is the attributes and the methods, which are the functions that operate on the data into a single unit known as a class. And encapsulation helps in hiding the internal details of an object and restricting direct access to some of its components. Another way of looking at it is encapsulation is wrapping up these attributes and methods together. Similar to a capsule you eat, like a medical capsule, it's all bundled or wrapped together. It's really about protecting the attributes, the variables and methods within a class, and you're able to restrict access to the variables and methods that form part of the class. So there are three naming conventions that are used, which are public, protected and private. However, in Python there are no actual keywords of public, protected and private, which there is in other programming languages like C++ and Java. So instead in Python we do this using something called access modifiers. And Python equivalent is the use or the absence of underscores. So using encapsulation and these access modifiers, we're basically restricting access to the class from outside of the class or the derived class. Public is the default and the methods and the variables are unrestricted and you are able to access them as you wish from anywhere within the program. Public does not use any underscore symbols before the attribute or the method, which means it's unrestricted. However, giving other coders the unrestricted ability to be able to access the class and modify things, they can, from a low risk perspective, do something that does not meet the requirements or the standard of the program, and from a high risk perspective, they can potentially break the program. So we need some way of giving coders controlled access. Then there is protected, and with protected, you can declare data members of a class to be classified as protected by adding a single underscore before them. However, with protected, it does not actually enforce anything. It's there to let people know that it's been classified as protected. So it's like a warning or a message to say the variable or method is protected, but it does not actually prevent access to the variable. And finally, there is private. The private access modifier is the most secure and enforces controlled access. Well, it does to the naked eye anyway. However, in reality, it's not that secure really. It basically performs a process called name mangling, in which it changes the name, so you can still access it if you was aware about the name change that happens internally on the back end. Anyway, we will have a look at this towards the end of the video. So with private, you can declare data members of a class, which are the variables and the functions to be classified as private by adding a double underscore before them. So in summary, with public, anyone can use that code within the class or outside of the class. Protected can be used within the class and within the child class as well when you're using class inheritance. But with private, nothing outside of the class can access the attributes and the methods, including no access from any child classes either, or derived classes. So to summarize, it's important to note that Python is a language that values simplicity and readability, and it follows the principles of we are all consenting adults here. So while you can use encapsulation to signify intent and provide some level of protection, Python does not strictly enforce access control like some other languages do. So developers are trusted to follow conventions and use encapsulation responsibly. And if we do use private, how do we then provide access? So with private mode, it stops you from accessing variables or methods from outside of the class or a child class. So how do we access private members? For this, we use something called getters and setters for when we want to access private data, the attributes and the methods. And getters and setters are basically methods or functions. You can call them functions. And with these methods, we can set conditions to make them more secure, which becomes more clear in the hands-on demo, which we'll be doing very shortly, after looking at the next part, which is the use case of why name mangling was introduced. So further looking into name mangling, Python name mangling is a mechanism that changes the way a class, attributes and methods are named to make them less likely to accidentally conflict with attributes from subclasses. So while many sources on the internet assert that name mangling is designed for establishing private attributes, actually its primary purpose is to mitigate name clashes in class inheritance rather than enforcing privacy. So name mangling proves especially valuable when safeguarding against accidental overrides of attributes or methods in subclasses. So the use of two leading underscores in attributes and methods can effectively prevent subclasses from unintentionally overriding them. So if you are creating a parent class which will contain attributes or methods exclusively for the base class, then it's in this situation where you would consider employing double leading underscores in their names. And this means you are able to use the same names in child classes, and you will not accidentally override the variables or methods in the base class, as this mistake does commonly occur. Right, so enough of the PowerPoint slides, let's look at a demo of encapsulation. Now we are in PyCharm and we will create a class called car, and then we create a constructor and initialization method and pass make, model and price as the attributes as part of the class car. We then create a list of our attributes, self.make, self.model and self.price. And next we will create our object instance and pass in the values. Because it's a car, we will create an Audi A3 and it will cost £5,000. So we'll specify the int value of 5,000. And next let's print all of these and run the file. And it's not finding the attributes because I have not specified a capital C for car. Should be car with a capital C to match the class up here. So it should find the attributes now. So let's create some print statements for make, model and price, and let's run the file. And we can see it prints Audi A3 5,000 to the console. And what else we can do is we can change the price. So even though we are outside of the class, we are able to change the price. So here is our class. It could even be in a different file. This is a very simple example. We may have thousands of files, and then we've got our object instance here. And because the class is public, there's no underscores before the attributes. Other people with access are able to make direct changes to the class. So let's run the file. And we can see that's changed to 6,000. So this is not a good thing. We need protection for our classes, especially when we are working on larger projects and other programmers need access to our classes. So we need a controlled fashion how other coders and programmers can access the classes without breaking anything, without damaging anything to our code, our classes. And this is where the getters and setters come into play. So using getters and setters is the most common way to give programmers access to classes in a controlled fashion. And we can set conditions for them as well, so they don't break the code. So for example, at the minute we've changed the price to 6,000, but someone else could easily change 6,000 using characters and convert it to a string instead. So something like this. Now let's run the file again, and we can see it's changed to 6,000. And of course this is now a string, not an int value. So this could easily break the code. We may have been doing something with the price. We may have been adding a percentage cost to the price. We may have been increasing the value by 10%. So it's not going to be able to increase the value of 6,000 written in characters with 10%. It's going to break the code. So this is where getters and setters come into play. And let's have a look at that now. Now to protect these values, we can specify a double underscore before them. So let's do this just for the price attribute. Double underscore. So two underscores creates a private attribute, and this means the attribute are only available for the members of the class and nothing outside of the class can access them. And now if we run the file again, we receive an error because the attribute is now private. Car object has no attribute price. So how are we able to read these values or write to these values? And we do that by methods known as getters and setters. So to read a value, we would define a method as part of the class. And as we are still inside the class and we're creating this method as part of the class, it's able to get the value. So we will call this getter method get underscore price, and it will return self.double underscore price. So the getter function get underscore price will help us retrieve the price in an indirect fashion, but let's also create a method to set the price as well. So that's again df to define the method. Let's call it set underscore price. And we will also pass a value to set the price of the new value. And itself dot double underscore price equals value. So now we use these two methods, these two functions, the getter and the setter, to retrieve the price from the class or to set the price in the class. So now we have the print function to get the make and the model, and we will change this one to the function c1.get_price, double click the method, and it needs an extra parenthesis at the end. So let's run the file. And now we can see it still retrieves the price of 5,000, the one that we set over here. And if we try and set the price, c1.price equals, let's go with 6,000, and let's run the file. We can see it doesn't change the price, so it's still 5,000. Or we can change it back to the string value 6,000 and run the file again, and we can see it doesn't change the value. It's still 5,000. We have a look at our car C1 and then the dot operator. We can now see we don't have the price available to us. So we've got the make available to us, the model available to us. We've only got the methods available now. The getter and the setter get underscore price and set underscore price. So we cannot change it. There's no double underscore price or there's no dot price. So the way we change it is using the set underscore method. So let's click set underscore price, and we can pass a value inside here. So let's go with 7,000 and let's run the file. And now we can see using the set method, it's changed the value to 7,000. Right, so now we have covered that. Here's the key bit on encapsulation. Now that we only have the setters and getters functions available to us to change and read from the class, well, what's the difference from accessing the class directly versus using these setters and getters methods? And this is because with these set and get methods, you can additionally have some validation code added to them. So it may be so you're not breaking the function with your code. So you can set certain conditions with a set method, for example, and this is the key concept of encapsulation. You set these setters and getters, and with these setters and getters, you control the access to the class itself. So let's have a look at an example of how we do this, and we use conditional statements. So let's set up a conditional statement on our set function. So set underscore price, and then we pass in a value as we have done here, 7,000. Let's specify a conditional statement, and let's say if the value is greater than 1 million. So let's print. That seems rather costly. Has there been an accidental addition of extra zeros added to the price? And then maybe we can do another one as well. If the value is less greater than 1,000, let's print. Let's print that appears to be quite inexpensive. Check the price again. And then finally else, we set the value. So let's scroll down and let's change this. Let's add some additional zeros. I've got 1, 2, 3 in there, so let's add another 3 and let's run the file. I've made an error. Let's remove the equal operator. So it's if value is greater than 1 million, and let's run the file again. Again, one more error. I've missed some indentation of the last statement, setting the value, and let's run the file again. So you can see our statement here. That seems rather costly. Has there been an accidental addition of extra added zeros to the price? Maybe I need to remove that. That reads better. That seems rather costly. Has there been an accidental addition of zeros to the price? Something like that. Now let's remove some zeros and try the less greater than 1,000 and run the file. And there we go. We get that appears to be quite inexpensive. Check the price again. So our conditional statement is so far working. If we add a 0, now it should hit the else statement and set the new value of 7,000. Let's go with 9,000. I think we used 7,000 before. Let's run the file, and we can see it's changed it to 9,000. So you may now see the benefit of using setters and getters. It's indirect access to the class, so it protects the class. It adds an additional layer of security, and you can control how programmers interact with the attributes within the class itself. Whereas if the attributes were public, programmers have unconditional access to the class. And finally, there's a single underscore as well. Let's add the single underscore before the model attribute and run the file. So we need to add it into our print statement, and let's run the file again. So we can see it runs. It's just a warning to say this is protected, but does not actually enforce anything, unlike the double underscore. So that's a high level overview of setters and getters, and you can see why they are beneficial. They give you that indirect access to the class, but it's very controlled. So you can set these conditions to say a programmer can access these values and they can change these values, but they have to meet a certain set of conditions. They cannot input something that will break the code, or they cannot input something that does not follow the standards that has been set for the class. And that's it. That's a high level overview of setters and getters. Now the one bit I forgot to show is the name mangling procedure that happens in the background. Now let's have a look at private mode in a bit more details, in particular with name mangling. So you can see self.double_price is in private mode. And what we can do here is if we print directory for the instance of C1, so it's print dir, so it's print dir and then C1 in parenthesis. Now if we run the file, now we see the directory for instance C1, which is this instance here. And the very first one we see is _car, which is the name of the class, followed by double_price. So our name is double_price, but it's prefixed _car, the name of the class, as part of the name mangling procedure. So we can see it's mangled the name with the prefix of an underscore followed by the class name. If we hover to the top here, we can see our class is called car. So it's prefixed it with the class name. And if I scroll to the very end, we can also see underscore model and the make attribute as well. And we can see our method set price as well as get price. So they're all at the end over here. But going back to this mangled name for the private attribute, what's to say we cannot use this name instead? So if we get the price for the mangled name, we can do that instead. So let's print, and it's C1 dot, and we can see the mangled name is hidden in here. So it's not visible in the options here, but of course we can type it in. So it's underscore car, underscore, or double_price. And that should do it. So if we run the file, we can see we get no errors and we do get the price back. So although we have set this variable to private, we're still able to access it using the mangled name. So therefore it's not very secure at all. And referring back to the PowerPoint slide, its real use case for using name mangling is to avoid name clashes with derived classes, so subclasses like child classes. So that's the real use case for name mangling. By the way, in this video we have mainly been looking at attributes and how to make them protected and private. But let's have a look at how we make a method private. So the way we do that, I've just copied a method, so I can just paste it in. So let's paste it in here. And the method is called public to private method. And then with it we print test public to private method. And how we make methods private, we just add a double underscore before them. The same as we do with attributes. So that's our private method. Now let's try calling it. So if we do C1 dot, and same as private attributes, we can see we do not see the methods, or should I say the private methods. We do see the set price and the get price. Those are the methods, the setters and the getters. But we do not see our new method, public to private method. And we do not see it with a double underscore or without a double underscore either. So you might guess what I'm going to do next. Let's try and access it with the name mangling procedure. Or maybe we should just run the file again to see if it's in the directory. So missing a bit at the end. Let's scroll back up and add the parenthesis self keyword and double colon. And let's run the file again. And now we can see our mangled name of the public to private method. And we can see it's prefixed underscore car at the beginning of it. So this is the name mangling procedure. So if we copy this, and then if we print C1 dot and paste it in, of course I've got to put my parenthesis in there and at the end as well, and let's run the file. So I've done that slightly incorrect. We're already having a print statement in there. We just need to call the method, and run the file again, and we can see it says test public to private method. So we could access it using its mangled name. And so now we have seen how to make attributes and methods private or protected, and how we can access them with setters and getters and enforce some conditions on them using conditional statements. And we've seen how we access attributes and methods using name mangling. And last but not least, let's not forget name mangling's main purpose was to avoid name clashes with subclasses. So if you've got the same names in parent classes and child classes, that's when you would use name mangling. That's its intent, why it's in Python 4. It's used to avoid name clashes. Thanks for watching Encapsulation in Python.